The topic we are going to discuss about is atomic structure, and the subtopic is magnetic quantum number. Let's define magnetic quantum number. The quantum number used to represent the degeneracy of orbits in space. It justifies the splitting of spectral lines in the presence of strong magnetic field. One of the drawbacks of Bohr's atomic model was जब भी हम spectral line को magnetic field में place करते हैं तो वो further fine lines में split हो जाती थी. So that splitting is now explained by the magnetic quantum number. Magnetic quantum number represents the degeneracy of orbitals in space. Let's see the characteristics of magnetic quantum number. Its values are m equals to 0, plus minus 1, plus minus 2, plus minus 3, so on. We can say it is plus minus L. The value of m depends upon the values of L. L की values depend कर रही थी n पे और अब magnetic quantum number की values depend करेंगे L पे. So these quantum numbers are very much interrelated to each other. So here you can see if L equals to 0, m would be 0 और s orbital की कोई orientation नहीं होगी सिवाय एक के. If value of L is 1 तो इसकी तीन degeneracies होंगी -1, 0, plus 1 that represent 2px, 2py, 2pz. If its value is 2 यानी कि इसकी 5 different degeneracies होंगी -2, -1, 0, so we have 5 different space orientations d 3d xy, 3d xz, 3d yz, 3d z square, 3d x square minus y square. In the next slides we will see it in detail. Here you can see on the basis of the values of magnetic quantum number orbitals की different space orientations हैं. S की सिर्फ एक ही space orientation है, P की 3 space orientations हैं, D की 5 space orientations है, F की there are 7 space orientations. So for a given value of L, the total values of M are 2L plus 1. Actually, the value of m tells us about the degeneracy of orbitals in space. It tells us the number of different ways in which a given s, p, d and f subshell can be arranged along x, y and z axes in the presence of a magnetic field. एक magnetic field की presence में एक orbit जो है p orbit वो किन किन axis के along lie कर सकता है. Thus, different values of m for a given value of L represent the total number of space orientations. Let's see the details of S subshell. For S subshell L equals to 0, so M equals to 0. Have one space orientation क्योंकि value क्या है 0, एक value है. Spherical and symmetrical in shape, probability would be in all directions. So here you can see एक ही space orientation है, it is spherical and symmetrical. That's why probability of finding electron would be in all directions. Next is P subshell. For P subshell L equals to 1, so M की तीन values होंगी 0, plus 1, minus 1. P subshell has 3 space orientations क्योंकि M की values 3 है. Arranged along x, y and z axis, thus perpendicular. Egg-shaped lobes होती हैं इनकी, disposed along orbital axis. So here you can see if they are lie along the x-axis they are px, if along y-axis they are py, and if along z-axis they are pz. In the previous slide I have mentioned that magnetic quantum number tells us about the degeneracy of orbitals. So let's see what are degenerate orbitals. In the absence of magnetic field, all the 3p orbitals have the same energy and thus are called degenerate orbitals. Since they are 3 in number, so these orbitals are said to be threefold degenerate or triply degenerate orbitals. P orbitals in the absence of magnetic field have same energy. That's why we call them degenerate orbitals. चूंकि p orbitals तीन होते हैं, p x p y p z, so we call them threefold degenerate or triply degenerate orbitals. Next subshell is d subshell. For d subshell L equals to 2, so m की values कितनी होंगी 5, 0 plus 1 minus 1 plus 2 minus 2. So have 5 space orientations, not identical in shape. p subshells जो थे वो identical थे shape में, उनका सिर्फ एक्सिस चेंज होता था, जबकि d subshells जो हैं वो shape में identical नहीं है. In the absence of b, they have same energy, thus are five-fold degenerate orbitals. p subshells जो थे वो तीन थे, उन्हें हमने ट्रिपली या थ्री फोल्ड डीजेनरेट कहा था. दे आर 5 इन नंबर, डी सबशेल्स, तो इन्हें हम 5 फोल्ड डीजेनरेट ऑर्बिटल्स कह रहे हैं. सो हियर यू कैन सी दे आर 5 स्पेस ओरिएंटेशंस और इनकी जो शेप है दे आर नॉट आइडेंटिकल, हर एक की जो शेप है वो डिफरेंट है. सो नेक्स्ट इज एफ सबशेल. For f subshell L equals to 3, so m की values होंगी 7, 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3. Have complicated shapes. So here you can see f subshell have very much complicated shapes. A question stated as a p orbital has dash energy than the s orbital of same principal quantum number, and the options are lower, higher, equal, variable, and the correct option is higher. Let's discuss a practice MCQ. The number of degenerate orbitals in a subshell having a sausage shape are 1, 3, 5, 7, and the correct option is 5. Sausage shape orbitals जो हैं वो d orbital होता है. So d orbital have 5 degenerate orbitals. So this was all about magnetic quantum number. I hope you have understood it well, and thank you so much.